I am in your science book, Fossils and Fuels. This is right after the soil lesson. I'm starting on page C20. I thought about the time we have left, which is not very much, and I have my cool box of rocks and fossils with me, and I get more excited about the fossils than I do the rocks, actually, although rocks are cool. I just decided that I think we need to keep moving because our time is short. And so I'm going to read the Get Ready box. I'm going to read at least part of this lesson, and when it starts getting too long, we'll stop it for the day and come back to it. So get ready. The objects captured in this piece of amber were once alive. Now I'm just going to kind of pan out here. Those insects are in kind of frozen in time. They are in a sticky substance that once was like sap, that when it hardened over time became something called amber. So the objects pictured in this piece of amber were once alive. Now they are fossils. Fossils tell us the story of life on Earth billions of years ago. Can you imagine how this might have happened? And then there's just talking about the process skill of experimenting when you perform a test to support or disprove a hypothesis. A hypothesis is an educated guess, what you think about something based on what you know. Now, there is an activity here. I don't have clear glue, but if you had some clear glue at your house, or you could get your hands on some, you could try this. And so you could read through this where you're actually putting some glue onto a plastic spoon, letting it set for a few hours, and then putting a little carrot slice on top, and then add more glue over it, and so that the carrot is completely covered. Then you're going to let it sit. Oh, put the other slice of carrot next to the spoon. So you put one carrot inside the glue, right, and cover it, and then you set the other one just out in the open air, and you compare the carrot slices, and then you kind of watch, right? How did the glue change the carrot slice over time? Will the carrot slice and the glue change more than the other carrot slice, or will the one that's sitting out in the open change more? And you can kind of make a prediction. So if you are able to do this, if you have some clear glue, you want to try not to put so much glue on the spoon that it'll never be able to dry if it's too thick, but put some and then stick that carrot in there and get enough to cover it, and then just let it sit out in the open. That'd be cool to try. If we were together, we could try that. We could get our hands on some clear glue. But this is similar to what would happen to those insects getting caught in the sap and then getting trapped as it hardens. All right, I'm going right on to C22. The main idea here is that fossils teach us about the past, the Earth's past. I think fossils are absolutely fascinating, and just seeing life preserved and how different it can be than what we see now. How are fossils formed? A fossil is the imprint or remains of something that lived long ago. People have found fossils that are more than 3 billion years old. First, plants and animals die. Their soft parts decay or are eaten. The hard parts, such as teeth, bones, and shells, last longer. These parts might become fossils. This woman is looking for fossil bones preserved in rocks. Wow, can you see those bones there? The animal dies, and somehow those bones and the rock that it fell on, or the soil, hardened into rock, and then many, many, many years later, someone unearths it and starts digging carefully. Now, the billions and billions, I always tell my students, scientists are always learning and studying, and they sometimes change their mind about how old things are. It's kind of an educated guess based on the science that we have at the time and the information. And so those numbers are what scientists think. And I don't know that they can be exactly proven. So I always kind of question when I see something that says it's 20,000 years old or 1,000,000 years old, and then to say they're 3 billion years old. That's amazing to me. I can't even wrap my brain around that. But scientists are trying to develop ways to determine how old things are. I know they're older than us, right? A lot older. Most fossils are found in sedimentary rocks, which we learned about. last week. Remember, these rocks form when silt, sand, mud, and other materials pile up and get cemented together. Sometimes these materials cover the remains of living things. This happens gently and quickly. The remains may become fossils as rocks form around them. Fossils are also found in amber. Amber is hardened tree sap. Tree sap is a sticky liquid that can harden like glue. When an insect gets stuck in tree sap, it may become a fossil in amber. So the conditions, I think, have to be right. If an animal dies, for example, and its body just lays on the ground, if that animal for some reason were to be where sedimentary layers were being formed, maybe in a riverbed or something, and the animal falls to the bottom of the river and lays there, if it's covered quickly enough by those particles, the body would be preserved. Or maybe it would be out in the open and rock is covering over the dead animal, and somehow it's all preserved, the bones at least. And that is the setting up conditions for fossils to form. Look at those. I have some of these in my box, some things very similar. We don't see things like that anymore, do we, running around or swimming around? One of these fossils is a cast. The other fossil is a mold. Can you tell which fossil is the cast and which fossil is the mold? The fossil on the left is the mold, and the fossil on the right is a cast. I think we're going to read about what those are in just a sec here. Shallow prints or marks in solid rock are called imprints. Living things made the imprints they pressed on the materials that later turned into rock. Shells often leave fossils called molds. A mold is an empty space in rock where something once was. Shell molds form after shells are buried in sand or mud. As water seeps in, it washes away the shells. Shell-shaped spaces are left. A cast is a fossil made inside a mold. A cast can form when minerals seep into a mold. As the minerals harden, they can form a copy of the mold's shape. So the shell might get washed away, but there's a space left with the imprint of that shell that it shows you exactly what that shell would have looked like. And if it gets filled with material that becomes rock, you have almost a recreation of that shell, I think is how I would interpret that. And of course, if you can get your hands on some clay, you can kind of make imprints with cool things. If you read through this, you can look at the imprints, and you could even have someone try to guess what you imprinted there. Mystery objects, right? So I'm going to stop the video at this point today, and then we'll continue tomorrow, and we'll dig some fossils out this week too.